everyone. Welcome back to another video. It's been a bit of a while. I've actually done a bit of development off screen, I suppose you could say. Been working on this issue here where the VGA driver is just not great, really. Basically it the scroll doesn't work. So what we can do is if we run this and do test puts s and just do that like a bunch of times, you'll see after a while it will like just crash out, and you can kind of scroll up one and it does stuff, but then not anymore. So at this point here, if we look at what everything is, we can see that the VGA driver is actually our biggest file. It was one of the first drivers that I wrote, and I think it's a good opportunity to refactor it and make it a bit simpler, and also work on something else. So there was another bug here of having a window manager feature. So I thought, hey, let's try and refactor this and come up with some sort of a notion of a window. So I've kind of done that, but there's some bugs left in it still, and that's what I'll try and do in this video today. So if we run this copy that I have, so here, I don't know, if we do the test puts s, we just get it panic. Okay, the tests are failing on this branch, but if we run help like a bunch, we can see that it's kind of one of those tests that you don't know if it fails. It might actually fail because I can't remember if I did that, but we can see that we can scroll. There's a bit of flickering, maybe a lot, I should say. And I've like taken hands off keyboard, and that was just like buffering. Scrolling down doesn't work at the moment, so that is one thing that we want to do. But speaking of the window manager size of things, if we look at help, we've got another command here, term, where we can resize and move stuff. So if we say term resize, I don't know, like, so this is 80 by 25, so if we said 40 by 10, say, it'll resize and redraw. As you can see, that it kind of works all right, and that seems broken. So there's a few bugs, but term resize, maybe if I don't print a bunch of stuff first. So that does that. I thought I had this good, but if I write term move and say 5, you'll see that it kind of jumped about. The scrolling is not working, as we can see, and if you scroll up it beeps. That was in my headphones, so you probably didn't hear it, but you might have. So what I want to do is kind of work on that, and if we look at our stuff now, we'll see that we've got a new file called term, and this driver is no longer being used. In fact, we would have to go into this, and that is our new VGA driver. So it's got a lot less responsibilities, which is probably more in line with what a display driver should be doing. So it's like, I don't know, a quarter of the size almost. So that is a lot bigger, and at the end of this feature we can just remove this file here, and this file will basically take over that, and also some of the window manager. At some point in the future we might actually refactor out this term to do a bunch of things. Now I've also included another kind of library, read key. Now this was kind of inspired by term ion, which is a Rust library, and what yeah, I think it's under here. So basically you can kind of read a key. It doesn't really like show examples on the thing, but the gist is that you can potentially, I don't know, if we go back, yeah, the README I think has a bunch. Yeah, we can kind of change the color. We can't do this at the moment. What the thing I've done is more this kind of matching what key has been pushed. So in this case, they kind of know that it's just a normal character and it's a queue, and you can have other kind of events. And what the read key is basically this event key has been kind of overridden. I think in the examples it might have a better example maybe. Keys, that would probably be a good one. Yeah, so here we can see whether a character's been pushed or like alt has been pushed along with a character, or escape, or like left, right, up, down, and that kind of just makes things a bunch easier. What I might do is, yeah, I'll keep that and make a comment in the description when I do that. There's another thing that I changed because of this read key. Now in shell, source util shell. So if we look at this, so read key, it's kind of weird. It doesn't do like a read first, which it probably should. So what we're doing is we're actually getting a character, then we're passing that to read key. So it kind of started off as like escape, whatever character is there. What this does is it returns a 4-byte integer, so a double word, and in the top byte, it basically has a bunch of flags, and the very most significant bit, if that's set, which is what this constant will go to, that basically means that it has some sort of flag. And if it's got some sort of flag, that basically means I've lost that. That's like way up here. That basically means that it will be in kind of not this state. So this state, that flag won't be set. These two we don't really have support for just yet, but potentially we will. But in these sorts of situations, that's when it will be set. So that's when we read key flag, and yeah, there's some comments that the shell probably shouldn't be doing this, but basically we test whether that flag could be like a function as well. So I kind of had it's inspired by this. It's not a copy of this. So I basically had an idea that say when you push the up arrow, then that might be a function that happens on the on the window manager. But in our case, we kind of have kind of both. So here we decide, we either run the function or we decide it's not a function, and then we check whether it is a key. So if it's a key, that is kind of one of these keys. Well, not escape. Escape's probably more like those ones. Oh no, escape I think is part of this, but it's not actually implemented yet. But it's reasonably easy too. So what we do here is if it's a key, then we jump to key. We first check whether we're just processing. Now this is kind of a hangover of, because we're passing in the character that we read, rather than just having the function do all the reading for us and just tell us at the end what the key is, which is roughly what this Rust library does. So the read processing is basically, it's come across a like escape character. It's in the middle of an escape sequence, so it needs to finish getting the input. So this is kind of a key to show, hey, go back and read another character and send us some more. And if it doesn't, then the shell checks whether it's cursor up or cursor down. Now, if I look at that file there, we fixed a bunch of bugs, but I think one of these we had like all this escape code, so all this red we've now gotten rid of. So we're basically double handling that escape sequence flow. So that's all good. What I might look at next, just before we get into stuff, just so you have kind of an understanding on what we have. So this is the read key. It's basically a state machine with various different modes. So we've got a normal mode, just general escape mode, and CSI command sequence introducer, I think it is, and SGR something graphics rendition special. There's this. Sorry, I'm just on the other window. There's this nice wiki page, which I'll probably include as well, basically showing all the escape codes that you might have, a bit of history about things, but here's where we kind of start. So here's some characters that do some control-y things. Key one here is escape starts all escape sequences. The rest are kind of, okay, that just does stuff, which we kind of do, but not in this library. Control sequence introducer is the one I was thinking of. So yeah, from here you can have like different bytes in that first byte, and that kind of says what type of thing it is. And then you've got other ones like CSI and SGR, which are longer, and the OSC will probably be another mode as well. So the CSI basically does a lot of stuff with the scrolling the cursor and raising stuff and scrolling, and it also switches to this select graphic rendition, which that basically changes the fonts, the font attributes, I guess, so whether it's bold or flashing or what color it is. Now with the colors, there's like a whole nutshell, colors are interesting. So the one we're using at the moment is just the 3-bit and 4-bit, and that's kind of a limitation because we're using just the VGA text mode. So we actually only have these colors because we store the color information for the text that we're writing in just 1 byte. At some point, when we redevelop the VGA driver to not be in text mode, and we'll display our own fonts at some point, we'll work at the 8-bit and then 24-bit and like all that fancy stuff. Because like maybe we want like this shade or like this shade, but at the moment we just have this, which I don't know, it works alright. It looks not too bad. So this kind of has a bunch of stuff. The CSI can also have parameters. How the CSI works is you basically have like unlimited parameters. Then when you end the M, so this M can be like unlimited characters, and when you do the M, it will basically process whatever the end was. So if it was 0, then it will reset. So you can do multiple, and I think there's an example here. Yeah, so like changing the color, you can have 39, then 49, then the M. and you can kind of just combine heaps. And like when you get into these ones, you need more. So yeah, so we read in the parameters, and that all works quite well. And when we process it, this is where we are like, okay, cool. We got a font reset code. So we basically check what character it is, and we like preempt what it might be. I'm not sure if this is the best way to do assembly, but hey, it works. And here you see that we know that this is just a function. It's not a key. You're just resetting the font. So that's kind of a hint to whatever's reading this byte to know, hey, like, don't try and think this is a key of some kind. So there's all that. And then if we look at the CSI one, here we've got cursor up, and we'll see that we say it's a key and a function, just because it's kind of used as both. Same with the page up. It can be either a scrolling function, or you might just want to see whether the page up has been called. So that's all that. And there's like a few other things that kind of go on here. Some to-dos. That kind of just explains how we do it. So if it's not SGR, if it's not a CGI mode, no, I think if it's a CGI, it will return the parameters in the middle 2 bytes, like that, which I can't recall if I have actually implemented that. And that's mainly like, it won't really happen on input because you'll push the cursor and it will just default to 1, which I think we might do, but we also might not. But yeah, the writing an operating system, there's always going to be bugs. But yeah, that's that file. Now, the final file that we're going to look at today is the new term, which we are going to just import, and I'll kill that over there, and open again. Cool. So this, we include like a bunch of stuff. So you see we're including the new VGA library. So this is kind of got the right function. So before in this, the puts, it used to just be something like that. Probably a rex at the end. So that used to be what it was, and I decided that's probably not the job of a VGA driver. So now it calls write, which is roughly similar to how it works on other systems that people might use. But yeah, we'll see how it goes. At the moment, we've only really got one output, which is terminal, but my idea is that if we have like a serial output driver, then this write will kind of intercept that and decide what output should it go to. Should it go to the VGA driver? Should it go to some other graphics driver? Or should it go to serial? Or should it go to a pipe or something that goes to the standard input of some other library? But yeah, so here we can kind of see what function keys that this kind of respects. So it does reset, and it also does page up, page down, does these kind of font resets, and it also does the set foreground and background. And the nibble is just because of that. It's 3 and 4 bits, so a nibble is just 4 bits, so that is why that is called that. And we basically have some functions for scrolling up and scrolling down. So if we look at scroll up line, the reason why it was flickering before, that's alright to ignore. So one thing is we don't really have a double buffer, which is something that can be useful in that. We do have a couple of functions on our VGA driver to scroll a kind of viewport up, which I guess I can demonstrate that if I comment out these ones. So by default it runs at kind of a small kind of thing, and I believe here it works fine here, so it's only after it kind of goes somewhere else and back, but the scroll down doesn't really work because that's a bit broken at the moment. But yeah, can we go back to, no we can't. Yeah, so the reason why it flickered lots is because ideally we would just do this, we would clear the line that we do, and then we would work out what to redraw in its place, but we also need to know where the bottom of the scroll is, so we basically shifted the line up. What I can do actually is not build, debug, and this kind of shows off that other feature that we did. So I might, do that sort of thing. And if we break on scroll up line, say, so if we do that, and we just enter one more time, and it should, I thought it would break on this. Yeah, that's where it's breaking. Yeah, because we were scrolling down before. This font is not good for that sort of thing. We have a lot displayed. What I might just do is undisplay all, and then move back there. So yeah, we can't really. What if we move that up there? That kind of works. We can only see one line at a time, but that's not what I wanted. Yeah, cool. That has crapped out. It's dying. Cool. No. That was a different crash to what I've had before. Right, so we'll move that back down there. We'll undisplay everything, and we'll do a break on, I guess, both. So here, if we're scrolling down, and we'll do NI, not just N. So here we do a loop to find stuff. So what I might do is just step to get to that. Oh, I thought that would. Alright, it doesn't. The debugger's just not happy with life. That is a different one. What I might do is just kind of switch between them, and undisplay everything. Cool. So if we do this, yeah, cool. So step kind of just does what we want now. So that first loop. Oh, I don't know why that's being so slow. It should. Yeah, that's a weird message. Cool. No. kill that. I'll try it one more time, and if it doesn't work, we'll get on to just fixing shit, which was the main point of this video. So if we step to there, we want to like break on scroll down dot redraw. So this is kind of a feature of the debugging symbols that I did. To get to this point here, we're still in the same method, so I can either at this point go to step I, which is step instruction, so it just does one, or I can go step, which goes to like the next like label, but that wasn't working before, so I won't do it again. Basically I did that, and then it kind of hung out in this loop for a while. That loop is finding this new line here, I believe. It basically finds where to kind of go next. But if we put in this another break, which we can kind of do a break inside of a thing. So if we do this, now we kind of get to that point. And now I might trust the luck with things. We have to go up here to see what we're actually running. Right, so the first thing we're going to do is scroll view down. So what that's going to do is, it's kind of going to scroll the view up. It takes a viewport, and this one I think is just this is actually kind of small. But what it will do, if I step over that, it kind of shifts everything up. So the down might not kind of make sense, but it kind of does. And then we clear line, because this little bracket here is actually this one from the second line up. So we don't actually want that there. So if we do that, it'll clear that bottom line. And now we call term redraw line. And what that will do is it will look at whatever we're printing, whatever's in our scroll buffer, and display that at this current line. And what we will find was there was actually nothing, because we're scrolling down organically, because we ran out of input. So we just leave. And at that point, the input, the shell takes over again, and it prints out this and kind of does that. What we can do now is if we scroll up, we can just see what that does. Not that one. There. We wanted to do this. So this also does like. Right, we scrolled too far. That's annoying. I've kind of killed what I wanted to do, because scrolling down doesn't actually work. But if we go down to scroll down line, I guess my whole point there was, I suppose that's all we really wanted to do. So what I'll do is one more time, I promise. Get things set up, undisplay everything, and break on this one, but only on the redraw. And that's got like tab completion as well, which it's amazing that we have all the maybe all of the debug symbols. Right, so here we are scrolling down. So what I might do is just do like an echo there, just to see what it is. Now if we scroll up, we're at this redraw function. So this kind of has the opposite. So here we can see it starts with if, and we've got like a line at the bottom there. when we do this scroll up, it kind of shifts everything down. So again, maybe that up and down is a bit misleading. I don't know. I'll have to think about the naming. And you'll see that first line is just kind of kept the same. Now, this is kind of an interesting one because the new line for this, because we're at this smaller viewport, the new line for this line, it actually wraps around and it's there, and then a new line actually starts for the link, and that's like a tab character, I think. So the problem is to find this line, what this line should be, which I think is, thank you for using my voice. We can't just assume we want to print from the start. Because say if we were kind of at this line and we were trying to work out what this line is meant to be, we need to know it starts with at this point here in that whole line. So the way we do it is we kind of redraw the line multiple times, which I guess I could show that as well. But we also clear that line. And so here we're like in a loop to redraw the line, and so if we redraw that, it redraws it and it stops there because that's where a new line happened. So at this point it knows, cool, we can just stop. That's the one we want. So yeah, I think that it went past the loop one kind of. I think that's just the last label. It's kind of gone out of the loop, but it's still in the wrong place. But the problem here is we don't know where this point is anymore because we scrolled up and we kind of had the same problem at the other end. The line was just a shell prompt with nothing on it, but we don't know how much we kind of removed from the scroll buffer. Like it might have been a line of like 80 characters, it might have been a line of 1 character. The end of it might have been after 80 characters and we need to go back 80, or we might have need to just go back like 2 characters because it's just a shell prompt, like a bracket then a space. So we've got an issue there that we don't actually know where that is. We can do it in a similar way, but we're probably not going to fix it there. This is kind of just explaining why there's flickering, because what we do next is basically say like, can't be bothered, and we redraw the whole thing. So we've printed that, we've worked out where the start of the scroll buffer should be, we reprint the whole screen, and at that point we know where the bottom of the scroll is. So here we just call term redraw, no change because there shouldn't be any change on screen after that call, but in essence what happened was it cleared the whole thing and it redrew it line by line, and that's what caused the flicker. If we had like a kind of double buffering system or a system to say don't actually display stuff, or like kind of refactored it so we can work out what offset it gets up to, that would be better. But for now, that is that. But yeah, let's stop that. And there's also comments on what we need to do and what we're doing for now. But yeah, scrolling down the line. So we can see that it works if we kind of just print stuff. It will scroll down organically. The only bug is if we scroll up then scroll down again. So I'm pushing page down, which is meant to scroll down, and it's not. And when I push an enter, there's like actually another prompt below it. So what I can do is type echo. Oh, maybe I'm like just lying here. I don't know. The scroll is a bit weird because say if we scroll up 3 times and scroll down, we only got down once, and we push enter, and it's like we can't do stuff here. And this term that's got like a space, it's got a space that shouldn't be there. That should be there. That's missing. So the scrolling down doesn't really work. And I've got some kind of comments on this. So what we're kind of currently doing is just seeing, are we below our viewport? That's basically what this if statement, I guess, is. Well, if jump. But that's not what we really want. That only really covers the like one of these. That really only covers this case here, where we're just scrolling down when more stuff is printed. And at that point, scroll bottom and cursor offset will be the same, and the output cursor Y will be greater than height. So we just test whether the Y is less than height. So if the Y is less than height, then we don't scroll. So if it's greater than or equal to height, then it does. But we're not actually checking this, and we need to check that because if it's equal and it's less than height, currently we just return and don't do scroll, which is good. But if the scroll bottom is less than where the cursor is at, that is an issue. Because at this point, we've scrolled up, and so the scroll bottom is not where the cursor is. Just to give a kind of more of an explanation on where things are. So at this point here, the scroll top is at this H. The scroll bottom is at this space here, and the cursor offset is also, it's either at this, I think it's at the blink. Yeah, it's at the blink. And the cursor offset is like an offset into the scroll buffer. These are all offsets into the scroll buffer. And so, when we scroll down a line, now the scroll offset is the T, but the scroll buff starts a line above at the H, and the scroll bottom is at this space here. And say if we type echo, and then we scroll up. So below here, which is hidden, we've got an echo. Now the cursor offset is at this point here, outside of the region, where it's the scroll bottom is here, where the cursor is currently flashing. Small bug, there shouldn't be a cursor flashing there because that's not where the cursor should be. I think I had this in the earlier version of the VGA driver as well. When we're scrolling, we should really hide the cursor. I might just kind of look at, so say if we, just do that. So this is using tmux, because like, you can have terminals that have a scroll, but I've used tmux for a while, and you'll see when you go in the scroll mode, it kind of shows the count of how many lines there are. So here which it's misleading. The 0 means we're at the bottom of 41 lines that we can scroll back, and if we go up to the top, now we're at the 41st line scrolled up out of 41 in the scroll buffer. And you'll see that the cursor, we can control the cursor and we can like copy paste stuff. So this is potentially something I will go forward to. And also like if it's got like kind of Vim style things, so we can kind of go forward, backwards. We can maybe do like a middle of the line, we can do the bottom of the line and top of the line. Stuff like that. And so, like, at this point, like, the input from the keyboard isn't going to the standard input, whereas in my one, it is. Like, if I go high, shouldn't have displayed there, but we had typed an echo before, and now it does like a weird high high, which that's not quite right. But if we push up, we can see the command that we did just run, which was echo high. So there's some bugs with the input when we're in the scrolled state. But yeah, we'll get to that. I don't know. It's real buggy. I'm like surprised it works. But yeah, so that's kind of showing how like a terminal scroll might work. Whereas mine, like, yeah, you can see that there's some more flashing now. Oh yeah, like now it's it just gets like real buggy when you start doing input again. So if we're like at the top, we push enter, it's kind of yeah. And then if we do that, then it thinks we're at the bottom, but then we scroll up. I don't know, it doesn't know where we are. And that is probably because we're not checking what we actually want to do. I realise I haven't actually done any coding. I've just kind of talked for nearly an hour on stuff that I've done off screen and how I might go about fixing it. But yeah, yeah, that scroll kind of works. Yeah, it's hard to know whether if I implement this sort of thing, it will do what I want. But what we can do is, right, if we move EAX, we'll get the scroll bottom. And we'll also compare that with cursor offset. So if these are equal, well, actually, if we're less than, then we are like in a scrolled state. Don't know if that's the right point that we are wanting, but yeah, I also wonder whether we want to check this. I wrote the note to myself, but I'm wondering. I think that's just what it was when it got called. Yeah, I think that's not right. That's literally the case that it was. So if we go debug, yeah, that's right. So if we undisplay everything and we just display term height, say, and also to display output cursor Y. Another cool thing you can do because of those debugging symbols. And then we want to scroll down line, and we'll just break on the scroll down line like that. So this scroll down line will just continue because we know it works. Maybe we'll put some content. We'll do those two. So I'll scroll down two. Now I'll scroll up one, and then scroll down. So here we can. That's not what I wanted. Undisplay all. We wanted to display DW. Yeah, that's what we wanted. And what was the other one? Term height. So here we can see our cursor is one below term height. So if we continue there, and this time if we say scroll up like 3, then scroll down, So, alright. Yeah, it's still like kind of one below the term height. So I do wonder whether we need to look at that. And I guess that kind of makes sense because if we, if we just run that because it's a bit quicker. If we try and scroll down now, well, at this point, like, yeah, say if we go to this point here and we term 0, 0, term resize, what is it, 80, 25. At this point here, I suppose it redrawed, so the scroll bottom is still the same as cursor offset. So yeah, I think we just don't need to think about that because if it is less than, then it just means that we're always in a scrolled state. So that means that if they're not less than, if the scroll bottom is not less than the cursor offset, it's either greater than, which is unreachable, which I potentially should do a thing, or it's just equal. Because where scroll bottom gets set, it checks whether it's at cursor offset already. Like if we search for like a so it sets it there and term redraw, and that's maybe it doesn't. Like here it checks. Yeah, no, that's a different thing. I don't know. Let's just go back to scroll. That's what I did. That doesn't exist anywhere else. So at this point here, we know that scroll bottom equals. So we've got those two cases. So, like, potentially, I actually wonder whether it will just work now. Look at that. Just that one if gets me going. So if we scroll up lots, then we can scroll down lots. It doesn't make a beep when I hit the end, so it's not doing anything now. But I think that is where did we go? Mark not set. I think that is because we just return. So if we look at scroll up line, we actually do a error, and the error is basically calling that. So what I might do is do a similar thing. And then at this point here, so we shouldn't be doing it. Error. Right, so at this point here, we shouldn't be scrolling, so that is when y is less than term height. So at that point it will do a little beep. I might just get rid of these for now. And then that means at this point here we kind of should be testing this. And that already works. So I think 40 minutes of rambling and then so if we get some output, we can test the output. If we scroll up, there's a bunch of output. So it should do a beep here, which you can hear like that. That's just my headphones by the laptop. And now if we scroll down, I mean, it's a sluggish feeling, and we're running this, not debugging. And here, it also beeps on the going down. So I think that's actually roughly what I wanted to do. Now, there's another small issue with scrolling. If we do test color, we've got color, looks like us. What's happening over here? What's happening here? It just looks kind of weird. If we turn 0, 0, and then what's happening here? Now it's all just numbers. Turn resize. What are we? 80, 25. Make the whole screen. And if we test color again, so it does it again, but it's still got like some weird artifacts. Because there was some scrolling happening at this point here. When we moved to the terminal, we were about here, so we could print this many lines. At which point we started scrolling, and scrolling doesn't really keep in account what font attributes were there. So you can see here we had numbers, and they're the same numbers that are in this list, but the colors kind of get overridden. So if I push page up, all the colors get reset. So we kind of just lose that information. And that flickering is a lot more obvious on the big screen. What I might do as a quick test is actually turn resize maybe like 60/20. So that didn't like. I think that did exactly what I wanted. Echo here. So if we, I don't know, resize to the big thing. So we see here it starts at str_rev, that line there. And if we resize slightly smaller again, it sticks with where that was. So the scroll bottom isn't where the cursor is, which we can see if we scroll down. That's where the cursor is. I think if we hide that cursor, that would be good. I think there's even to-dos about hiding the cursor when we scroll as well. So if we scroll back to the big one again, so if we scroll down to here, get chart is at the top. That's a bit weird, because get char was like 2 lines down, and it had like a weird thing. Man, now that I put in that beep, it's actually quite annoying. I was thinking of doing like a visual bell type thing as well, just to save my ears. But yeah, or potentially like a lower volume. I don't know. What have we done? We've nearly done now. We've actually fixed the bug that I wanted to. It did take 40 minutes of just rambling and then about 5 minutes of fixing it. But I mean, you saw that I had the comments on what needed to be done. So what I might do is just rename those. Yeah, that kind of does that. So the resize needs some work, and the color stuff needs some work. Now the colors, I think if we search for, like we want to make like. At the moment, we've kind of got just a font. So we've got this term font, and that is our current term font. Oh yeah, that's right. We like add in like a built-in, which probably shouldn't be in here. It should be like in a utils folder, kind of like how we have we have a lib for music, but then we also have a util for music to so like this stuff below, which is a couple hundred lines, probably shouldn't be there, because that's like, I don't know, just it's a command line tool in a way. But yeah, where I was we have this font, and it's kind of a static font that gets updated. So when we set the background, we get the current font, and we set the background. We don't actually save what it was in the stream. So when we're going in the scroll buffer, so we've got a kind of capacity of the buffer. What I'm thinking is, along with the scroll buff, and we can fit like 100 k in there, which potentially that needs to go. And I also don't know what happens when we go over. So moral of the story is we might not actually fix this bug, but we've also made it a lot cleaner in my opinion, and a lot less dependent on. Yeah, it's more like modular in a way, whereas the old VGA driver knew a lot about what text was, what scrolling was. Like, it just shouldn't do that. I mean, at some point the scrolling will probably get pulled out of this, and this will only know that it prints things, and that might have a hook to say, I also know how to scroll things, but here's the file that you should call to do all your scrolling desires. But yeah, less kind of more modular is good, because then you can test things kind of very modularly, and it kind of works. Yeah, so what we kind of want to do, and also this isn't very multitasking friendly at the moment. My idea is that, so we have a term here, so if we like no tab completion, believe it or not, say if we like resize the 1010, so that's like a tiny one, and you'll see it started from where it already was, but we should be able to scroll down. Yeah, look at that, we can scroll down in this real narrow window, and we get to the bottom. That's pretty cool. And if we do that, it kind of works. There's a lot of spaces printed at the end there, which is why that wrap's so funny, but we can also scroll up and it works. I don't want to like hold it because it makes the beep. But I guess where I'm going with this is I kind of want to adapt this, and kind of the term is just the text in the middle, and then have a notion of a window that might have a border, so we can have like a title bar and a border, and if it's a scrollable thing, maybe have a scroll bar also drawn to the side there, and from there we can have multiple of these windows, and when we write stuff, it will write wherever we're like kind of focused, so it will have the kind of notion on where we're focused. But it's still quite a ways away, but I think it's good to kind of look at what the future could have. But yeah, I think I'll leave it for here, and hopefully I'll do another video doing the kind of color output. I guess that's another library I added, was it's just an include. It's basically just a structure that can store some attributes of whatever font. At the moment it's kind of tailored towards the VGA driver, but it's extendable, I guess, if we get another display driver that can support more colors, or something like that, or the font is saying what actual font set it is, then yeah, that might be quite good. Might be italics or something like that. basically it's more extendable and it's not all just in this behemoth VGA file. What I might do is I'll ignore that and look at what we did. Yeah, so all the code we did is put in that like one if statement really, and have a build. But yeah, I'll commit that up. So this is on a different branch. So we're on VGA Refactor, and my idea is probably after I get the color scrolling right, I think that is basically a similar state to where it was before, and it will potentially still have this bug, but it'll be in a lot cleaner slate because refactoring is good. But yeah, what did I do here? Allow scrolling back down. So yeah, I'm pretty happy with that. So I'll push that up, and yeah, that's the video for today. If you enjoyed watching it, let me know somehow. Otherwise, I'll see you next time for colours, I guess, unless I just do that on my own. But no, I'll probably do a video of it because I find the videos good for talking out ideas. It's kind of like the rubber ducking debugging technique, if anyone's heard of that. But yeah, anyway, have a good day wherever you are, and I'll see you next time.